Welcome, everybody, to the SAVE lecture for January, and we would like to start off with a prayer.
Okay, good evening and welcome, everyone. My name is Nancy, and I am going to share a prayer. Well, that kind of sounds like a poem, but actually, this is a prayer from Pope Francis on climate change. Fill us with peace that we may live as brothers and sisters, harming no one. O God of the poor, help us to rescue the abandoned and forgotten of this earth, so precious in your eyes. Bring healing to our lives, that we may protect the world and not prey on it, that we may sow beauty, not pollution and destruction. Touch the hearts of those who look only for gain at the expense of the poor and the earth. Teach us to discover the worth of each thing, to recognize that we are profoundly united with each creature. Encourage us as we pray in our struggle for justice, love, and peace. Amen.
Thank you, Nancy. Welcome, everybody. This is a lecture by Science Alliance for Valuing the Environment. SAVE is an educational consortium for environmental sustainability. The mission statement for SAVE is that the Science Alliance for Valuing the Environment fosters a personal awareness and respect for the interrelatedness of ecology, spirituality, and sustainability. SAVE creates formal and informal lifelong learning opportunities in collaboration with organizations at all levels, local, national, and global. SAVE's activities are designed to empower individuals to values-based action for a just and sustainable world. SAVE was established back in August of 1990 by a group of concerned citizens who wanted to make a difference and promote a love and appreciation for our natural world. SAVE's actions have gotten down to these particular areas. We provide scholarships to underserved youths for science camps. We provide special environmental awards at Northwest District Science Day. We present environmental awards at our annual awards night banquet. Eco Educator Awards, Eco Service Awards, Eco Friend Award, Eco School Award, and Eco Community Awards are just some of the awards that we hand out. We also sponsor bi-monthly public lectures, of which tonight's featured guest, Chris Vickers, is our latest. Also, we want to thank our SAVE corporate sponsors. Among our, also added to our membership, they include Budget Blinds of Toledo, the Baha'i Community of Sylvania, Ohio, Luber Plate, Sophia Center, Lourdes University, Franciscan Village, Holy Spirit Community, Catholic Community, Wild Birds Unlimited, Sylvania Franciscans, the Butterfly House, and Wright Financial Groups, LLC. And at this point, I'd like to pass it over to Dave for his introduction for Chris Vickers. Dave, go ahead.
Evening, everyone. Our guest speaker tonight is someone that's probably very familiar to all of you, unless you haven't been a citizen of Toledo for the last month or so. Chris is the member of the WTOL First Alert Weather Team, and he's been there since 2008. Graduated from Ohio University with a Bachelor of Science in Meteorology and a minor in Physics. He's a member of the American Meteorological Society. He earned a prestigious distinction as a certified broadcast meteorologist. He actually has received 2 Emmy Awards, one for directing the station weather coverage in 2012 for the local impact of the Hurricane Sandy, and again in 2019 for coverage of the Dayton Memorial Day tornado outbreak. He was also honored as the first place recipient of the Ohio Associated Press Best Weathercast. He's a weather fanatic, living out his childhood dream. He enjoys studying severe and hazardous weather, including the formation and generation of tornadoes. He also enjoys reporting on snowstorms, which I think we're getting a little of tonight. The flakes are falling, and lake effect snow as a great passion that has perked his interest in the field of meteorology as a kid. In addition to weather, he enjoys studying our climate and seeking solutions for current environmental issues. He's also, this is a very interesting fact, he's a determined supporter of the St. Jude Children's Research Hospital and ending childhood cancer and other life-threatening diseases. He brought the St. Jude Dream Home giveaway back to Toledo in 2017 and was honored to win the 2018 St. Jude Champion of the Year Award in Detroit, in addition to the incredible recognition of accepting the 2019 St. Jude Dream Home Campaign of the Year Award at St. Jude in July of 2019. Quite an accomplished individual. I'd like to present Chris Vickers. Yes.
Well, thank you very much for that introduction and that welcome. I appreciate it. And it's a pleasure to be with everybody this evening. And I think we can all agree on the common ground that we can't wait for some snow tonight, right?
Right.
You know, it is the middle of January after all, but yes, we have a little light snow coming. Just one of the things that I have passion about, of course, is the weather, but also talking to people and educating people about our environment, our climate, and our potential impacts on our climate as well. So I'm going to go ahead and take the screen over, and I will get started with the presentation. And it is quite an honor to be with everybody as we get rolling. All right, you should be able to see my screen just fine. Are we looking okay on everybody's end before I get rolling?
Mm-hmm.
Okay, wonderful. So if you guys have any questions, feel free to stop me as we go through this presentation. I intend for this to be very visual. It's my job and my nature to be presenting things in a visual way. The only difference tonight is when you're at home and you see me on the TV screen and you shout something at me, I can't hear you. I can tonight, though, so that's the benefit of being able to interact with you. So careful what you wish for and what you say out loud. It will be picked up and I will respond. So that's part of the beauty of being able to interact with people, and something that I have a passion about doing as well, being able to talk and voice some common concerns and common goods that we hope to accomplish. If you're more comfortable as well, maybe voicing something in the chat, we could have that chat open as well. Feel free to contribute in that way, shape, or form. So we'll get started this evening. And again, thank you so much for allowing me the time to speak with you. This is something that I've really grown in my passion for, as evidence of our changing climate, I think, is around us each and every day. There isn't a person in this world that the weather doesn't impact on a daily basis. And think about it. The weather impacts what you do tomorrow. The weather impacts what you're going to wear tomorrow. The weather can even impact how we may feel tomorrow. The element of sun this time of the year certainly perks our mood up and makes us feel a little bit more alive and awake. And the range of temperature that we're going to experience through the day impacts how we dress for the day. And depending on the weather type, it impacts potentially what we do. A lot of people don't realize, though, that the general changes and trends in our climate also impact us, maybe not to as much of a noticeable degree on a daily basis, but certainly over time and through generations, and it will and can have impacts on our future and certainly the future of the ones that we love. So I talk with various groups throughout the course of the year, and many of these groups range from anywhere from kindergartners to high school students, to college classrooms, to educated groups, to groups that are energized and willing to learn on specific topics. So I say that I can talk to everybody. So I intend this to be informative, starting with some basic information, but also then visual with a lot of visuals on how I can help explain and relate this topic. So I'm going to start with something very basic here. What is the difference between climate and weather? So generally speaking, climate is just the average of conditions of the atmosphere over periods of time. We describe climate in maybe annual rainfall. How much rainfall or precipitation does Toledo see through the course of the year? Average temperature, the range of our temperatures. When does our average frost or freeze occur? And annual snowfall. These are just examples of what we talk about when we talk about climate. Now, it's important to note that climate, it changes over decades and over centuries. So it does change, and it does change naturally. Weather, on the other hand, the state of the atmosphere currently and on short-term variations. It's the temperature, it's precipitation, it's wind, and it's humidity. I've always been told, and this is a good way to remember it, climate is what you expect, weather is what you get. And I think we can probably all relate to that. Weather changes hourly and daily, which is what makes my job so incredibly fun, trying to predict the fun weather here in Northwest Ohio and how it changes every single day. And I have certainly a strong passion for doing that. So what is the reality of climate and weather prediction? I mean, this is easy stuff, right? Look at your screen.
Oh, look at that.
Here's some of the primitive weather forecasting equations. We have an ideal gas law, Newton's second law of motion, a hydrostatic law, conservation of mass applied to the atmosphere, a zonal wind, meridional wind, temperature wind, precipitable water, pressure thickness, hydrostatic equations. These are just all the easy weather forecasting equations, right? Who thinks this looks more like a foreign language on their screen?
Yeah, it does.
It is. It is a lot of complex science that goes into what we do to predict not only our weather, but our climate over time. It's not simply just measuring, recording, and analyzing data. It's a lot of weather forecasts and equations, and everything that we basically do is run by what we call numerical weather prediction. So what is that? It's supercomputers. So everybody right now, you're sitting in front of a computer screen, right? Do you have a supercomputer or is it a regular computer?
Regular.
That's what I figured. Unless you're really a high-tech super scientist, you've got a regular computer, okay? What we use, though, in the weather forecasting world to predict the weather and help us assist predict the weather is called numerical weather prediction. So where is this? Well, it's run by the National Oceanic Atmospheric Administration's National Center for Environmental Prediction. So basically, we all own these computers by virtue of us paying tax dollars to the US government. Our tax dollars help fund weather research, weather models, and computer modeling. Specifically, it is the Environmental Modeling Center that runs these computers. Now, time for a quiz. I didn't expect to give you guys a quiz tonight, but I hope you came prepared. So our computing systems, they are a dual system with a computing power soon to be upgraded from 2.5 petaflops each to 12 petaflops each. So who's a brave one? Who wants to take a guess at how much computing power is a petaflop? What does a petaflop mean?
No clue.
And I'll ask a more specific question then. How many mathematical calculations is a petaflop? How many mathematical calculations is a petaflop in 1 second? So how many calculations can be done in 1 second in one petaflop?
100,000.
100,000 is first guess. I need at least 2 more guesses.
Let's say it's more than 1 trillion.
Okay, we've got 1 trillion.
Over 1 trillion.
Over 1 trillion. Anybody else? I always like to get 3. Anybody going once, going twice? All right, here it is. So our supercomputers that are responsible for calculating and running daily weather models for weather forecast and for climate models, 12 petaflops equals 12,000 trillion calculations per second.
Oh,
Every second. Now, before you take your computer off of mute and ask me, well, why can't you get the weather forecast right in your 7-day forecast if you can do 12,000 trillion calculations per second? I've heard that one before. Well, remember this, though. It is numerous calculations of an infinite atmosphere that goes into these primitive weather forecast, weather equations that are run by, and get this, these supercomputers are some of the most powerful supercomputers that are on the face of the earth. It's hard to find a supercomputer that is stronger than this, and it is run to, and it is used to run computer modeling for weather and climate. It's pretty fascinating. So the number again, 12,000 trillion calculations per second. I believe that's 12 quadrillion calculations per second is what that number comes down to. So let's kind of shift gears a little bit into what are our known drivers of climate. We have solar output, we have the orbit of the Earth, we have the tilt of the Earth on its axis, we have the Earth's eccentricity, we have greenhouse gases, carbon dioxide, methane, water vapor, ocean currents can affect our climate, volcanoes, and something called albedo, which is the Earth's value of reflectivity. How much of the solar radiation that comes in gets reflected back into outer space. Clouds tend to reflect a lot of solar radiation back into outer space. Land masses tend to absorb a lot of that solar radiation. So I need to highlight sort of a difference because there's going to be something that we distinguish a little bit between this discussion here. You probably have heard both these terms, climate change and global warming. Quick show of hands, probably have heard them both before, correct?
Yep. Yes.
I would say so. So global warming, just to get a base definition, describes the observed and the projected increase in globally average temperatures over time. Because our global climate is a dynamic system, global warming has occurred in the past and it will occur in the future. Climate change, this indicates and includes warming and the side effects of warming, such as melting glaciers, heavier rainstorms, more frequent droughts, and heat waves. So the big question is, what and how much is anthropogenic or human or man-made influence on our dynamic climate system? And the real difficult part about this is, since climate is a moving target, it naturally changes over time. How can we measure, determine, detect, and then attribute what is changing in our climate directly to what we are doing as humans? So that's the challenging part, and that's the difficult part. So what are greenhouse gases? Because this is a big focus of it. So what we do as humans with fossil fuels and developing other forms of energy in our day and age releases greenhouse gases, carbon dioxide, methane, water vapor into the atmosphere. Now, the main emission of CO2 through burning of fossil fuels has been noted and documented over quite some time. I have a video here, and I'm going to click on this link, and I'm going to pull up a quick video. And you should be able to still see my screen. Everyone can still see it just fine, correct?
Yes.
yes.
So this is a very cool animation from NASA that shows a year in the life of Earth's CO2 cycle. So I want you just to watch this, and I'm not going to speak.
I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere.
Lost you.
Visualization compresses.
Are you guys able to still hear the voice that's narrating this?
We're not seeing it or hearing it.
You're not seeing or hearing it.
I'm hearing it very faintly.
Okay.
Me too.
Carbon dioxide emitted from remains in the atmosphere. while the other half is absorbed by natural land and ocean reservoirs.
Chris, on your screen, you should be able, on the top right, expand your menu and make sure share my computer sound is on.
I turned up my volume and it was better.
Yeah.
Let's see.
Is controlled by the
Yeah, I
large-scale
do
weather
see where
patterns
it's
within
paused my
the
sharing. So it doesn't want me to play a YouTube video right now, I don't believe.
Okay.
Oh,
That's okay. We can move on from that. It was just going to show a life cycle of carbon dioxide. All right. You should be back. Are we back now?
Yeah.
Yes.
Okay. Well, hey, that's the beauty of Zoom. You're not sure exactly what's going to work and what's not. So ultimately, it comes down to our greenhouse effect. Now, our greenhouse effect, without the greenhouse effect, life on Earth wouldn't exist as we know it. This essentially, like a greenhouse that grows produce or vegetables or flowers in climates that aren't suitable to otherwise grow them, protects our Earth with a very thin envelope of gases that are very important around and in our atmosphere that trap in the right amount of the Earth's or the sun's energy that is emitted to Earth. Now, the greenhouse effect, while it's naturally occurring, can and is influenced by greenhouse gas emissions that we as humans release into our atmosphere. So generally speaking, as a scientist, when we look at data, I could show you a few things as far as data would prove what we've seen and what we've observed as scientists over the past several decades and now longer than a century or more with good atmospheric data. So 2020, the average US temperature, and this is some new data that was just confirmed by multiple organizations, the entire global temperature was 54.37 degrees. That in itself was over 2 degrees above average or above our baseline trend of 1895 to 2020. And over that time, we've seen approximately 0.16 of a degree Fahrenheit increase each and every decade as far as a baseline trend. Now, as we get towards more modern times, we see an acceleration of that trend. We see higher extremes in that trend as well. And 2020, by many standards, was not only the warmest year globally, it was also one of the warmest years or the warmest year in the United States history as well. So the map you're looking at right now is statewide rankings broken down by each and every state, from what was the record coldest to below average to near average to above average, much above average, or record warmth. How many of the 50 states saw below average temperatures this year?
none.
0.
None. Yeah.
Exactly. So all 50 states recorded a statewide average temperature rank that was above average. The majority of them were much above average, with some of them very, very, very close to the record warmest of all time. Florida, Virginia, Maryland, Delaware, New Jersey, Connecticut, Rhode Island, Massachusetts, Vermont, New Hampshire were all in their top 5 warmest. Ohio was the 6th warmest statewide on record, and several other states in the West were one of the warmest on record as well. Add to that our precipitation rankings. This is a pretty interesting map because I think it shows very stark disparities between parts of our direct country here. From some parts of our country that had the record driest years on record to states that had very close to the record wettest years on record. So 2 things you probably heard a lot about. Did you hear a lot about wildfires over the past several months?
Yes. Sure enough.
Absolutely. Part of that is an ongoing drought or drought that may have been, it may be persisting now for what we call a multi-decadal drought that is occurring across the West Coast. California, Nevada, Utah, Arizona, Oregon, Washington, all very dry. To the south and to the east, any explanation why it was so wet across the southeast this year?
Hurricanes?
Hurricanes. The incredible tropical season that we had. Did anybody know so much about the Greek alphabet after this
Oh,
year?
we learned.
We learned our alpha, gamma, alpha, gamma, beta. Yeah, we went on through the Greek alphabet farther than we've ever gone in modern times. So that resulted in an extreme amount of high precipitation across much of the South and East. So our global temperature trend, and this is a similar map that I showed you just a few moments ago. And we can see the trends that have been ongoing over the past, 140 years since we've had good, atmospheric data and measurements, and especially, since the 1960s, 70s, and 80s, especially when we went into satellite era, we had some very good data on the amount of warming that was occurring in the atmosphere. Does anybody have any specific questions up to this point, or does something not make sense that you want me to kind of pause and just give a little clarity to?
Chris, what about Alaska? Was that also, did I miss that or?
I didn't have it. This map was just the lower 48. I'd have to go
Okay.
double check on what Alaska was, but their climate has been rapidly warming as well. And I'll show some data coming up here that
Okay.
Locations more poleward or toward the poles are warming at a much more significant, much more rapid rate
Okay.
than mid-latitude locations as well. Good question, though. Very good question.
There
Yeah.
were a number of very severe storms that hit the East Coast. I mean, David Muir reports, wrong channel, but reports his breaking news is a huge storm hits the East Coast. But you're showing that area to be drier than normal. I'm surprised at that.
Much of the East Coast was near average. Once you got from the mid-Atlantic up into New England, part of that was because, and you may remember this, the eastern 2/3 of the country had an exceptionally dry period of weather from May, June, July, August, and into September.
Mhm.
So there was a lot of dry weather that offset that through the course of our summer months that were very hot and dry. So it was just sort of an offsetting impact.
Chris, on this last global temperature trends, 1880s to almost 1940, it looked like we had much colder weather,
True.
below zero averages and things.
True.
Am I correct?
Yes.
Yeah.
Yeah, absolutely. Yes. And, some of this goes into recent and far reaching paleoclimatology of where our Earth has been in its history. Our Earth is 4.5 billion years old. Billion. So to think about that and to think about the multiple temperature trends that we've gone through the course of that time. There's been some recent studies, though, that show that the Earth has experienced periods of temperature that have been hotter today. We know that. But by far, it's the recent trend that we're seeing right now and the acceleration of that trend that many scientists believe is unprecedented even in historical times.
Wow.
So if we just consider the past, let's say 11,000 years, natural variability, and I'll have some graphics that can explain this that go out into a little bit of a longer term trend, but natural variability can basically be explained why our temperatures moved in the manner that they did. But the only explanation in recent times and recent trends and the rapid rate of increase of those temperatures, generally speaking, points almost directly to greenhouse gas emissions that have accelerated over the past several decades. So I think it'll be a little bit clearer when we go out. I'll have a couple graphs that go out a little bit farther in time or a little bit farther back in time. I think it's important to note, and you'll see a very similar trend between these two graphs from here to here, that this data is independently verified by multiple organizations in this day and age. We're now into the year 2021. So there are now global efforts all across the world studying what we know about global temperature trends. For example, this map shows the NASA Goddard Institute for Space Studies, the Hadley Center for Climate Research, the NOAA Center for Environmental Information, and Berkeley Earth. They've all done independent research studying this, and they've come up with essentially the same trajectory on where we've been and where we're going. So the data is good. The science is good. We just need to figure out how to apply all this to educate people and to minimize what our impacts are on global temperature trends. So some of the data that shows up are 10 hottest years globally on record. By some, it is so minutely close between 2020 and 2016. They've essentially been declared a tie. Most recently, it was last week that the NASA Goddard Institute for Space Studies came out and actually ranked 2020 as #1 as the warmest year globally. And it was hundredths of a degree difference between 2016. But you notice the trend here. Our warmest and hottest years globally, the top 10 of them, 2005, 2013, 2010, 2014, 2018, 2015, 2017, 2019, 2020, 2016. So it's pretty clear where the trend has been. The global temperature departure from average, similar map that I've shown you, just kind of reinforcing some of those values and the changes that we've seen over time. Most recently, we've had several years now that have eclipsed over 2 degrees in a average departure globally of above normal temperatures. And this on a global perspective, not for any just given climate location or any one specific location. This is global data that it was derived by NASA, that is confirmed and that is reinforced by satellite measurements that are capturing a more broader picture of what is going on in our current climate. You may or may not have seen this. Some of you probably could be very well familiar with this. An organization called Climate Central is big in getting people to visualize how our climate is changing, because that is one of the things as a scientist and a social scientist that we're finding is it's very difficult in this day and age, especially with how polarized people are in their own beliefs. And unfortunately, in either direction, misinformation that they can find on any given topic, it's very difficult to get people to understand how things are changing. So this is a graphic that's very well done and put together by Climate Central that shows our stripes, essentially. It's called the warming stripes. And each stripe across the screen is a year in history. And it shows with a corresponding color how that has changed globally over time. And it's pretty clear from the cooler colors to the warmer colors that we are in fact in a warming climate. This is one of the maps that I kind of will refer back to that I was asked about recent trends up toward Alaska. So this data was from 2019, and I wasn't able to quite pull 2020 yet, at least visually. The data, while they've released the statistics, I wasn't able to access the graphics quite yet, but it will look very similar to this. And you'll notice the Arctic is warming at a rate of up to 6 times faster than our global average. So I always like to discuss with people when we're talking about our climate in general and our change in our climate. Our change in our climate goes so far beyond what somebody here in Northwest Ohio observes with their eyes. You cannot make a just conclusion on that without understanding that global warming or climate change is a global phenomenon. It is occurring all across the globe, and some areas more than others, it is occurring at a much rapid rate. You can see Alaska up there in the top left corner of your screen. The anomalies in 2019 were astonishing at how warm Alaska was. Some parts of Alaska were over 10 degrees Fahrenheit warmer than the typical average. And in some isolated areas, they had departures that were even farther beyond that. This past summer, the anomalies were most extreme in northern Asia up towards Siberia. You know, I saw something interesting today where it's ironic because Siberia this time of the year is experiencing some of their coldest weather on the face of the planet. They've had temperatures down to 70 below zero, 70 degrees below zero Fahrenheit. So it gives us new perspective on our wintry weather. There was a specific city, though, in northern Siberia that this past summer hit 100 degrees Fahrenheit for the first time ever in its recorded history. And today hit 69 degrees below zero. So it was a temperature departure of nearly 170 degrees difference.
Jeez.
Isn't that incredible?
Yes.
Yeah.
Pretty incredible. So just understand, though, and this is a good visualization of what is happening to our climate globally, that it is increasing and Arctic is warming at a rate of up to 6 times faster than the global average. Probably not much of a surprise then, you know, our annual Arctic sea ice extent since the late 1970s has just absolutely plummeted. It's had some minor fluctuations over time, but the trend line is down. Some recent data shows 2020 was at essentially about the all-time low. And to put this more so in perspective, the sea ice extent currently up in the Arctic is about 220,000 square kilometers below the previous record. Not below average, below the previous record. So another 220,000 square kilometers of Arctic sea ice that is shrunk away up in our Arctic, that is continuing to shrink at really rapid and astounding rates. One of those, obviously, is the Greenland ice sheet and the mass loss that's occurred even in more recent times. This is over a period of about 18 years. This is trillions of metric tons that have been lost. So starting back in 2002 to the most recent data has about 4.5 trillion tons of metric ice that have been lost just from the Greenland ice sheet. So obviously rising sea levels is going to be something that is going to be a very significant and very potentially dire characteristic of climate change that will be going forward, especially considering, and it's not just unique to the United States alone. In fact, many would argue that we're more suitable to adapt to climate change compared to third world countries that, you know, exist on coastal regions that would have no way of adapting to rising sea levels, thus creating, you know, more famine, more poverty, potentially more war, potentially more suffering and pain. And many of you are probably familiar with Laudato Si as well. Francis's encyclical talked extensively about that as well. And who are the most vulnerable to, you know, climate change and changes in our environment and changes in our atmosphere. Any questions up to this point?
You know, it's something when you go to Alaska and you tell people that you went there, they say, "Oh, I wouldn't go there; it's too cold." But they don't realize what's happening in the bigger picture.
Absolutely, and I'll tell you, and I'll argue this, and I'll have something coming up too. I mean, do you feel that our climate is changing as well?
Yes.
Oh, yeah.
And I'll have some data to ponder how much I believe that it's actually changed even in more recent times. So I'll highlight that coming up in just a little bit. So let me recap. I know it's so nice to think about warm summer days this time of the year, but our summer of 2020 was quite extreme. We had the second warmest on record, our second warmest summer on record. Our average temperature, this is the average of our daytime highs and our overnight lows, averaged 75 degrees through summer. Our average daily high of our summer season was 86.8 degrees. We had 35 days at 90 degrees or warmer. Now, historically, we average about 16 or 17 days at 90 degrees or warmer. So we were over twofold or double what we typically see for 90-degree days in the 2020 season. I think this is even more astounding and something that has been not only detected but attributed to climate change is that it is very common that overnight lows are becoming much warmer in locations all across the globe. We had 17 nighttime lows at 70 degrees or warmer. It's one thing to get the summer heat, but when you get the summer heat that is followed by oppressive overnight lows, you increase the risk of heat stress, heat exposure, and heat exhaustion, which is something that could be exacerbated by urban heat islands, the growing impact of larger urban areas, warmer climates, and warmer overnight lows that could create big issues with people with asthma, breathing problems, other problems, respiratory problems, that makes it exceptionally difficult for people to breathe and to live a longer, healthier, fuller life as that climate gets warmer. We also had a moderate drought through our summer. There were weeks there, and you may remember these, that boy, we just couldn't buy a drop of rain. It got pretty dry through our summer, and that dry weather sort of helped feed some of those drought conditions. So I want to give kind of a quick run through of where our average summer temperatures have gone over time in the Toledo metro. If we look at our specific data since 1871, and that's where we can really go back and get climate data, we actually haven't seen an overall enormous upswing in our average trend line. It's only been up about 0.2 of a degree. The thing about this is, though, the trend since the 1970s, so if we break that down to the last 50 years, where our greenhouse gas emissions have really started to increase and ramp up, it's been a much different story. In fact, our average summer temperature has now increased over the past 50 years on a trend line of 3 degrees Fahrenheit. Our average summer precipitation, this map was pretty interesting as well. Shows that the trend line over 50 years for summer precipitation is flat to slightly lower. So what we're seeing, and what we believe we're seeing, is more persistent, stagnant weather patterns that are leading to longer durations of dry weather throughout the summer periods. And then when we do get rain, we get heavier convective rainfall that tends to give a whole lot of rain in one sitting instead of spreading it out over a longer amount of time. You probably, if you've paid a close attention to the news, one area that's been directly impacted by that 2 times in a huge manner is the city of Findlay and the flooding of the Blanchard River, getting hit with heavy convective rainstorms in the summer months that have hit the Blanchard River basin, flooding it with over 8 inches of rainfall in a 6-hour period, resulting in catastrophic flooding in the city of Findlay. So summers in Northwest Ohio, our data can show since the 1970s, so we're talking about 40 to 50 years now, our summers have become increasingly warmer, neutral precipitation, but with the caveat that we're getting longer dry periods filled in with heavier bursts of rain that break that up eventually. How about winter, though? Everybody's got a story about winter, right? Does anybody have a story about winter? And I'm guessing
Yes.
some of you are going to go to the winter, the blizzard of 78, right?
Yeah, right.
Correct.
Yeah.
That's kind of what I figured. So, you know what? I've plotted the data for an average Toledo winter temperature. Now, there's been quite a bit of variability over the past 140 years or so in Toledo's annual temperature. What we've seen, though, since the extremely harsh winters of the late 70s is a pretty significant increase in our wintertime temperature. We've seen that played out in a trend line over the past 50 years, a rise of about 4.6 degrees Fahrenheit is where our winters have trended over the past 50 years. Winter precipitation has been increasing. Our trend line is 1.65 inches increasing over the past 50 years. So we can say that Ohio winters, sorry, that went a little quick on you, are becoming increasingly warmer and increasingly wetter. Now, that doesn't necessarily equate to more snowfall. It could be more rain and more heavier rain events. And with our precipitation becoming more, more heavier rounds of precipitation, with a warmer climate, the Earth's atmosphere can hold more atmospheric moisture, especially in the winter months where it's not accustomed to, thus increasing the amount of precipitation that can and does fall, sometimes occasionally in winter storm situations. So any questions on that?
Chris, why, I'm sorry, I'm going back a little bit. Why the heavier precipitation all at once? I don't understand the reason for that.
So the reason for that is that we're having more frequent dry spells. And is what happens is during the summer months, even though we're having more dry spells, our atmosphere is still loaded with higher moisture content.
Oh.
So when it's like when you shake up a bottle of pop and you finally blow the lid off, it goes, right? So it's more likely to see heavier rainfall. We call it precipitable water. It's the amount of water that we can actually measure within the column of the atmosphere. And it's estimated that every degree Fahrenheit that our climate warms, the atmosphere can hold 7% more moisture. So
really,
in a year like last year, you could argue that potentially our atmosphere was holding anywhere from 10 to 14% more atmospheric moisture.
wow.
So when it holds more atmospheric moisture, if you encounter a certain weather pattern, it can rain really hard. And one of the things, and I'll discuss too, there are certain things that we can attribute to a change in climate, and there are certain things that we scientifically can't attribute to yet. One of the things that we can attribute to is a higher frequency of heavier rain events. Scientific data can attribute the increase in higher precipitation events to a change in climate. Two words you need to remember on that one: detection and attribution. Can scientists detect a weather event? And then can we attribute that to climate change? We can't say that with all weather events. And I want to make that very clear. So you can't blame every weather event on climate change. It doesn't work that way. Some of them you can, though. Some of them you can. It's an important distinction.
Is
So I
that
told
why
you I
we
was-
had?
Go on.
Is that why we had more hurricanes this summer?
That's a very good question. So most data, and here's what I will say, and I'll get this, I'll put this one out there. One, we have not been able to yet identify the increased number of hurricanes as a direct correlation to man-made climate change. But we can attribute rapid intensification of hurricanes to man-made climate change. And if you followed along closely this year, how many of these hurricanes did we have that if you turned on the news on Monday, it was a tropical storm on Monday? And then if you didn't turn on the news for 24 hours and you turned it on Wednesday morning, it was a Category 5 hurricane 50 miles away from the Louisiana coast. And you thought, what on earth just happened? This was a tropical storm 48 hours ago, and now it's a Category 5 hurricane. There were more hurricanes this year that underwent rapid intensification that have ever been measured in our history. So that's a pretty good distinction to know. We've not yet been able to attribute an increase in hurricanes to climate change, but we've been able to attribute rapid intensification of those, and potentially then higher amounts of rainfall, higher winds when they do make landfall. and potentially greater devastation as they do make landfall. Does that answer that question?
Yes, thank you.
Absolutely.
Chris, what about tornadoes for this area? Are we seeing more or less of that in our summer months?
So that's another thing, that there's no data to suggest that we can yet attribute an increase in tornado frequency. In fact, the data doesn't even suggest that we're seeing an increase in tornado frequency. So we have not been able to actually attribute that to climate change, and more importantly, man-made climate change. In fact, when we look at it historically too, the higher level or higher end tornadoes, EF3, EF4, and EF5 tornadoes, there's not a statistical correlation. Those have been increasing over time. In fact, some data would actually suggest that there's been a slight decrease in higher frequency tornadoes. And here's what I'll argue too, is that a lot of this is more awareness to them now. Our advancements in Doppler radar, we detect and see every tornado that ever occurs. There are storm chasers that swarm every tornado. And if there's a tornado anywhere, it is out on YouTube, Facebook, Instagram, the news feed, national news networks. You see it everywhere. Would that have happened back in the 1950s?
No.
Not a chance. We didn't have the distribution of media at that time. So part of that with tornadoes is we are more aware of them now. They're better detected now. And a tornado doesn't occur anywhere in this country that's of significance without you hearing about it or without it being broadcast all over news networks. So I think it's more just a social science aspect of it. We're just more aware of them right now. So
What about,
yeah, go on.
about the snow? Like Texas gets what, 3 feet of snow or something, and we have little trickles here. What causes that?
Well, two things can cause that. Sometimes it could just be the luck of the draw. Sometimes that's just how it happened. You wouldn't have said that in the winter of 2013 and 2014 and 2015 and 2014 and 2015 when we got crushed with snow. But part of it is too, some science does suggest that due to increasing temperatures globally, that it disrupts our polar jet stream, which our polar jet stream separates the mid-latitudes where much of the United States falls with the polar locations. So it allows for what we call a more wavy, undulating jet stream, which allows for occasionally, as ironic as it may sound, intrusions of colder air farther south because the jet stream is not able to, it's more wavy now. So it kind of wiggles all over the country instead of being in a more confined area. So it's ironic as it sounds, it's sort of difficult to explain, but without a very stark temperature contrast and overall warmer climate, it weakens the polar jet stream and allows it to wander a little bit more.
Thank you.
Mm-hmm. So here's just some data showing of Toledo specific data. So this is where we live, Toledo, showing that 2020 averaged our second, or actually was a tie for the warmest year in Toledo's history. So somewhere between the second warmest and warmest, it was a tie for the warmest with our average mean temperature of 53.4 degrees. So one thing I want to point out with this, and I told you that I would come back to this when the question was about, traveling to Alaska and it being too cold. This data then compares what our short-term climatology for this past 12 months was and what it would compare to geographically to our historical climate. Toledo, and it's in the top corner of your screen, acted this past year more like Cincinnati, Ohio. So Cincinnati, Ohio is what, about 180 miles south of us? What many would consider Southern Ohio a much more mild, tame climate. And our climate last year geographically matched or correlated, had an analog closest to Cincinnati, Ohio, based on our average high temperatures, our average low temperatures, and how warm we were through the course of the year. So I think that's truly incredible when we talk about a changing climate Well, put it to what does it mean to me when we say a change in climate? It means that last year, living here in extreme northern Ohio felt more like living on the Ohio River down towards Cincinnati, Ohio, is what our climate felt like. So, a question?
Beverly, poisonous snakes.
I only caught the end of that. I'm sorry.
Go back, Beverly, with your question.
I understand.
The question is, if we're getting to be like Cincinnati, are we gonna get poison snakes up here?
If we do, I'm moving north.
Oh, black snakes.
All joking aside, I don't do snakes well at all. I will tell you that for sure. But one of the big things that is being studied with climate change is the changes of migratory species, especially birds and insects, pesky mosquitoes, big impacts with changing climate on mosquitoes, bird migration patterns, animal migrations. Absolutely, that any of that is on the table. There's no doubt about that. So I'm going to bring up a few visuals here, and I'm going to go through this a little fast because it's a couple years old now, but I think it brings up a very good point too. Visually, if you're ever talking to somebody about climate change in our local area, we've had proof that it is occurring and it has occurred. So 2017 was actually a very extreme year for us, and you may remember this. September of 2017. I've never seen anything like this in my life in the month of September. We had 6 days in late September at 90 degrees or warmer. September 21st through September 26th were 6 straight days at 90 degrees or warmer. In Toledo's recorded history, and the bottom graph is the temperature trend through the entire calendar year of 2017. You could see, and I've highlighted on the top graph, where the month of September got very extreme with the warmth, and you could see how it maxed out with record high temperatures. 4 of those 5 days were record highs at 90 degrees or warmer. February of that year was also the second warmest February on year. So our season of warm weather really was almost February through late September. It was truly unusual. Now, why I point out the 2017 September heat wave. Does anybody remember this? Some of you may. Some of you may not remember it, but if you didn't remember it, you remember it now, right?
Yeah.
Because this is what happened to our river. September 21st through the 26th of 2017. The 90-degree days, the unusual heat, the abnormally dry weather, the stagnant weather pattern basically heated up our Maumee River, the western basin of Lake Erie, to abnormally warm temperatures that were beyond what was typically normal for this climate region, and allowed an algae bloom not only to develop but to thrive in our Maumee River and western Lake Erie basin. This wasn't the middle of summer where we do get algae blooms. This was late September where we had these algae blooms. This is high resolution satellite imagery from outer space showing that algae bloom, how visible it was from satellites high above our Earth looking down on our lake. So one of the graphs that I have to show, that extreme heat wave caused that huge spike. So the red line that spikes up is the Lake Erie water temperature that spiked up in late September, and that extreme heat wave that showed a huge spike in that water temperature. So pretty incredible with how extreme that was. So I always like to show that because as I said, sometimes climate change is difficult for us to visualize. Well, I think that kind of puts it in perspective for us. So greenhouse gases and climate, obviously a lot of this is tied to CO2. So that temperature trend that you've probably gotten fairly familiar with seeing now from the late 1880s also mirrors that gray line, which shows CO2 levels. And within the past 12 months, for the first time in modern history, our CO2 concentration measured out in Hawaii has surpassed 400 parts per million for the first time in modern times. Now, I've said this before too, our Earth's climate has changed before, and it will continue to change in the future. So we use ice cores and paleoclimatology to try to discern and discover what has happened in the past, to use it as a barometer for what's happening right now and what is considered within a normal range and what is not considered a normal range. So that trend I just showed you over the past 400,000 years has shown that we have had some significant fluctuations in temperatures over time. It has also mirrored changes in the Earth's carbon dioxide cycle, which there are cycles. Some of this is tied to what's called the Milankovitch theories, where it's changes in the Earth's orbit, changes in its eccentricity, changes in the tilt of the Earth's axis. Many reasons. Scientists still debate about the exact causes and reasons of it. But what's clear, compared to what's happened based on this ice core data, even over time, even though some of these increases look fairly significant over time, they still happened, generally speaking, over thousands or tens of thousands of years. So they still happened over a fairly large amount of time. What's happening right now, and I'm not sure, I want you to be able to see this. So for me, my box of Zoom people is right on the edge of my screen. You need to be able to see the far edge of your screen right now. So you might want to grab your window if you're not able to see it. So here's the Earth's temperature trend over the past 11,000 years. So there's a temperature estimate and a range of uncertainty, but can you see what's happened with the purple line at the very end of the screen?
Yep.
Yeah.
It is gone from what has been somewhat of an explainable change or curve based on natural climate change and natural climate variability to what we consider a rate that is unusual and unsustainable. Let me give you an example of that. Okay, so at the very end right there. So it's a little humor here, but is this sustainable? I took that same graph right there. If the global temperature anomaly was this ride, would it end very well?
No.
So again,
Down.
it's the overall trend and the rate at which things are occurring. So it's the rate at which our climate is changing. So I don't really do much with policy and climate and politics, but I think it's important just to at least mention it at this point. What is the Paris Climate Agreement that was set out back in 2015? It was considered a landmark international accord that was aimed at combating climate change. Now, this deal required, or at least set targets for countries to set their own targets for reducing greenhouse emissions by 2020. This was something that was put forth in the Obama administration, and the U.S. was committed to reducing our carbon emissions by 26 to 28% by the year 2025. This is some important numbers if you want to jot it down or to remember, and if you continue to do climate studies, these numbers are important for target goals. So countries are expected to aim to keep global temperatures from rising no more than 2 degrees Celsius or 3.6 degrees Fahrenheit by the year 2100, with an ideal target of keeping that temperature rise below 1.5 degrees Celsius or 2.7 degrees Fahrenheit. This data basically was set by the Intergovernmental Panel on Climate Change. So this is something that is independently studied and set with these target goals of keeping our temperature somewhat within a range of what we expect could be something to mitigate some significant impacts. So the agreement also established $100 billion fund to help vulnerable countries to deal with the effect of climate change. I think the focus, of this group in particular isn't just about the environmental aspects of what happens with climate change, but also the humanitarian aspect. I'll circle back to, Laudato Si, which I think is a fantastic, encyclical by Pope Francis, which establishes how vulnerable third world countries are and will be to a changing climate in the future. So with ratification by the European Union, United States, and China, the agreement did obtain enough parties to enter into an effect as of the 4th of November, 2016. It was considered an unprecedented international agreement among 196 countries at the time. Obviously, I would look for, with the changing political climate in our country to this date, there's expectations that we may be hearing news headlines tomorrow about what the U.S. intends to do with the Paris Climate Agreement. So to be continued. Stay tuned for breaking news, right?
Hopefully.
That's the cliffhanger I'll give you.
Yeah.
I mentioned a little bit on the IPCC as well. They are in the midst of right now their 6th assessment cycle, which I believe is set to be completed and released next year in 2022. Each assessment cycle, their language has gotten more clear and more direct. Their last one from AR5 said that it's extremely likely that 95% confidence that more than half of the observed increase in global average surface temperature from 1951 to 2010 was caused by anthropogenic increase in greenhouse gas concentrations and other anthropogenic forcings together. So a pretty strong statement. And again, it's saying it is extremely likely that at least half of what we've observed is directly due to man-made influence. So we can debate all day how much, but I think it's pretty clear, and I think we all pretty much understand that in some way, shape, or form, man and the way that we use fossil fuels is impacting and negatively impacting our climate and our environment. If you ever choose to dive down that rabbit hole and look more at the IPCC, global warming projections, this is just sort of a projected path of where they want that net emissions to be limited to keep us from exceeding that 1.5 degrees Celsius threshold by the year 2020 or 2100, year 2100. So I think this is kind of an interesting flow chart, so to speak, to look at, coming off of that statement that says that at least half of the warming that we've observed since 1950 can be attributed to that. Because it is also fact that climate is both a mix of natural variability, which is on the left of your screen here, and anthropogenic climate change. Both of them go into that dynamic climate system that we experience to develop what we know as weather and climate events. Where these all overlap, weather and climate events overlaps with vulnerability and overlaps with exposure, and we get our disaster risk. What we need to do then is to take that disaster risk, understand and develop risk management and climate change adaptation. Also add to that climate change education, climate change policy, climate change understanding. It can go on, but we need to develop and redefine the way that we've been doing things and the way that we've been thinking. Vulnerability to climate change. Notice the countries that by the IPCC have been designated as the most vulnerable countries to exposure and susceptibility, socioeconomic fragilities, and lack of resilience. What countries do you see here? Nicaragua, Jamaica, Guatemala, El Salvador, Honduras. These are poor third world countries. And these are the countries that are going to be least able to adapt to a changing climate going forward. So again, could further increase the humanitarian crisis. So some of the risk of climate change, droughts, heat waves, flooding, extreme precipitation events, both in lack of precipitation and in heavy precipitation, loss of sea ice, rising sea levels, coastal flooding, wildfires, rapid intensification of hurricanes as well. So I debated putting this in. I like to include this. And even if you just take a few elements away when you're discussing climatology, climate change, weather with people, there's a lot of psychology that goes into weather and climate. So each person individually and uniquely can interpret data, the reality of science and weather, strikingly in different ways, right?
Yeah.
Tomorrow, I could go on the news tomorrow and I could ask people how they would describe the weather. And I would get people describing the weather, which actual weather, the high of 30 degrees, light snow, and a cold wind. And people describe it in many different ways. Correct? True?
Mm-hmm.
Right.
So the psychology of weather and climate acts in similar ways. So two terms I'm going to throw out to you. Our mind, when we talk about weather and climate, can go through something called cognitive dissonance as well. So it's going to be our mind's tendency to seek consistency among our thoughts and beliefs to avoid mental stress, discomfort, or contradictory beliefs. So basically this says that we believe information that fits our thinking. Now take today's not only current weather situation, but also our political climate as well, right? Do we find people using cognitive dissonance to find information that fits their original thinking so they can back up a point right there? That allows them or motivates them to reduce or minimize other scientific data to think it's less important. Okay, so we need to watch out for that and avoid that when we're talking about weather and climate. We don't want to alter the importance or criticize other data points just to make our mind believe something that we want to believe. Trust the data. The second thing is a confirmation bias, the tendency to interpret new evidence as confirmation of one's existing beliefs and theories. Just today, I shared information on the news and on my social media accounts about Siberia hitting 70 below zero. Do you know how many global warming scam comments I got on my Facebook page? Because it's 70 below zero in Siberia, global warming isn't happening. So that's an example of someone trying to use a confirmation bias, saying that that can't happen then. There was also snow in the Sahara Desert. I saw camels with snow on them this week. People could use that as a confirmation bias to say, well, global warming or climate change can't be happening. Now, it can go both ways, though, okay? A flood can happen, and I've heard multiple people saying, well, there's another flood. That has to be climate change. Bottom line is, no singular weather event can be directly 100% tied to climate change. Climate change can influence certain weather events, but it doesn't necessarily cause weather events. It can enhance, change, or alter them, but it doesn't necessarily mean that that event is totally tied to climate change. I'll go through these maps because I know we're starting to run a little short on time here. There's some very interesting data and research that's been done by Yale University on a climate change opinion map. This will give detailed metrics and studies on what people believe about climate change, okay? And I just took Wood County in our area because I always like to call Wood County a bellwether county, right? You hear it in the political season. It's a pretty good mix of what Northwest Ohio is about. Mm-hmm. So 68% of Wood County thinks that global warming is happening. That's about 2% below the national average. Watch what happens here, though. So that was just a question of estimated adults who think global warming is happening. Now, the estimated adults that think global warming is affecting the weather, that drops down to, I can't see the number, I think 60%, drops down to 60%. And you'll notice it goes even lower when you start asking more detailed questions. The next question is, I went too far on you. Estimated percent of adults who think global warming is most caused by human activities. That drops now down to 54%. And now you're starting to see the blue colors come in across much of Ohio that show that the majority of people think it's just natural changes. And again, it could be, it is a little bit of both. And then perhaps maybe one of the more telltale signs, the Yale Climate Opinion Map had research on estimated percent of adults who think global warming will harm them personally. And that drops to 36% of people. So 2 out of 3, or a third of the people say it will harm them personally. Most people don't care or don't think it's going to harm them personally. So what's going to be driving people to action if they don't think it's going to harm them or impact them personally? So the data shows now many people think it is happening, but people don't think it's going to impact them personally. Any questions on that up to now?
No. Depressing.
So there's the data right there. 68% believe global warming is happening. 60% believe global warming is affecting weather. 54% believe it's mostly caused by humans. 36% believe that it'll actually harm them in the future. So again, that's just what people's opinions are. But that matters because opinions eventually shape policy. Policy eventually shapes what we do. It is certainly all connected. So some of these questions were already asked too. What are the linkages to extreme weather? 2020 had $22 billion disasters in the United States. You can obviously see our Gulf Coast was littered with hurricanes. Hurricane Hannah, Delta, Laura, Zeta, Sally, Ada, and Isaias, impacting the United States in billion-dollar disasters. The other ones, I believe there were 13 of them that were severe storm-related, 1 wildfire, and 1 drought. And obviously, you could see the fall wildfires, Northern California, Western wildfires, California, and Oregon and Washington firestorm. That was a huge one as well. 22 separate billion-dollar disasters. 7 of them were tropical cyclones, 13 severe storms, 1 drought, 1 wildfire. The past 4 years have been quite historic, with the average annual number of billion-dollar disasters more than double the long-term average. And the number and cost of disasters is increasing over time due to a combination of increased exposure, increased vulnerability, and then the fact that climate is changing and the increased frequency of some types of extreme weather that is leading to the increased billion-dollar disasters. So it, again, is not purely just climate change. Part of it is our vulnerability. Part of it is our policy and our exposure to certain types of weather. If we continue to develop and build houses out west in areas that are prone to natural wildfires, you can't always just blame that entirely on climate change. Part of that is policy of where we choose to develop and expand, and if that's wise to be doing that in the future. I'll zip through these, and then we're basically towards the end of it. One thing that's been very interesting, and I do a lot of talks with agriculture around this area, farmers in particular, our length of our growing season has dramatically increased. Our growing season is now 11 days longer than it was in 1980. That growing season both is a combination of our fall frost coming much later in the season and our spring frost, last spring frost, occurring much earlier in the season. So a divergence of that is lengthened our growing season. So that is something that has changed. I just wanted to throw a bunch of these out here. We talked tornadoes, right? There was a question specifically about tornadoes. Look at the trend in the number of tornadoes that has happened. I cautioned you on this, though. Even though the data says there's an increase in tornadoes, is that really a trend, or is it just better detection of tornadoes? A lot of the data suggests is we're just better detecting tornadoes. A lot of this is proven by the fact that stronger end tornadoes, EF3, 4, and 5 tornadoes, have actually decreased. Low tornado counts over the past several years included 2018. There were no EF4, no EF5 tornadoes in the United States that were confirmed. That was the first time that had ever occurred since 1950. So there's been years where we've had a lack of tornado activity. Hurricanes, the number of hurricanes, and I don't have the absolute latest data from 2019 and 2020, but I will put those on here because especially 2020, which was right up there with 2006, would be off the charts. Is it a trend or is it better detection? Similar questions on that one. And again, our detection and attribution of that is still yet to determine, because we can actually look at another metric of hurricane. We call it the ACE index. It's accumulated cyclone energy. It generally shows that there isn't a higher amount of cyclone activity globally. They may be becoming stronger and more intense quickly, but the number of hurricanes and the total overall energy of those hurricanes has not shown any dramatic increase. So the final questions that I think we should all ponder moving forward is, how can we reduce our impact and our footprint? I am personally speaking, I'm so beyond, climate policy and this or that. To me, as somebody that just wants to care for our environment, it just makes sense to me, right? There's no harm, in my opinion, of moving forward with clean, renewable energy just on the premise of taking care of our environment. And obviously then reaping the benefits of a cleaner environment, not only for us, but for our future generations, cleaner energy. What weather phenomena can we continue to tie to a changing climate? And again, those two important words: what do we detect and what do we attribute to climate change? Because not all weather events we're going to be able to detect and attribute to climate change. What is the renewable energy future and realistic net zero emission goals? It'll be interesting to see what happens with the new administration. What are the adaptation and mitigation steps to reduce climate change vulnerability? Some of the recent studies, I just was in a discussion group that was talking about last year, Hurricane Michael that hit Mexico Beach, Florida. You heard of all the devastation. There was some research done on some of the homes and structures that were recently built down there with new building codes in place. In the direct eye of a Category 5 hurricane, the homeowner didn't even file an insurance claim on his home because he only lost a few shingles and a couple shutters.
Wow.
And he got hit by a Category 5 hurricane. So listen, there's ways that we can be smarter about this and how we do this. Now, granted, I don't know what the cost of that was for him to do that, but it just at least shows that it's physically and feasibly possible to be building to mitigate and adapt to damage lost. Who will be impacted most? And what are we doing to educate ourselves and to make a difference? Because I'll be honest with you, the greatest impacts are not going to be to any of us on this Zoom call right now. It is going to be to those that are much less fortunate than us, those that are in third world countries, and those that will suffer the greater consequence. We have a moral obligation to make sure that we're preserving our earth and our environment in a feasible and in a responsible way, not only for us, but for our future generations, and certainly for those that are more vulnerable to that. That is my presentation I have for you guys this evening. If you have any final questions, I hope I left a little time for that.
I have a question. I think I heard David Attenborough on TV the other night suggest that the U.S. had more of these billion-dollar events than any other country on earth. What do you know about that?
I don't know. I don't know the specific citing of that one, but that makes sense to me. That seems just about right to me. But again, if I go back to, if we went back to that slide that showed $22 billion disasters, how much of that is self-inflicted too, right? For building in coastal areas that maybe weren't sustained or suitable for, a hurricane to arrive. How much of it was for lack of management of undergrowth and brush in the West Coast, and building in areas that we shouldn't, and human caused arsons or campfires that started some of those Western wildfires. There's so many explanations. The fact is, yes, to that. The number of billion-dollar disasters in this country is unacceptable. There's no doubt about that one. I wouldn't dispute that, and I don't know that directly off the top of my head. I would imagine without a doubt that by far that is more than any other country in the world. But yeah, some of it's got to be our adaptation, our vulnerability to that stuff. What can we do to mitigate that? And how can we prevent those in the future? But I would say that
the point was we seem to be paying less attention to it than other countries, but we have the greatest loss.
Yeah. Greatest loss is certainly financially, I would say for sure. But, the economic, hardship and human suffering from other countries that can't adapt to it or in many ways, shapes, or form, foot the bill as we are able to do in a wealthy country such as the United States of America. It's much harder for them to brace for the impact of what they would experience in that. Take Puerto Rico and Haiti or Dominican Republic. When they get hit by a hurricane, it could set them back a decade.
Okay.
Any other questions? I
want to thank you for this presentation, and I am certainly a bigger believer in climate change now than I was a day ago. But I wanted to ask you, what causes the gray days in Ohio during the winter?
Wow.
Oh boy. Yeah, boy, you're throwing a zig and a zag into this one. The atmosphere this time of the year has a lot of lower atmospheric moisture content that gets trapped under temperature inversions. So basically, imagine this: it's a lid that gets put on our atmosphere, and the moisture gets trapped underneath it. Most of you have probably traveled by airplane in winter months, correct? Right? You've gone somewhere warm. How long after the plane takes off do you see blue skies and sunshine?
Not very long.
About 90 seconds after the wheels are up, right? You get right up to the shallow cloud deck, and you're up into the atmosphere that's crystal clear and blue skies and smooth sailing. So it's just the fact that there's a little lid on the atmosphere with colder air at the surface that traps that moisture in. It's just a cloudy time of the year.
Mm-hmm. Chris, when they say that the Arctic's melting and that the lakes and rivers and oceans are going to increase, will that affect the St. Lawrence Seaway and our Great Lakes also? I always you hear, well, California and Florida are going to suffer from this, but I wondered about the water trickling into our area and going up also.
Right. I don't believe that to be the case, with the structure of the St. Lawrence Seaway and how the lock system works, and, the whole Niagara Falls thing. And, it's a cascading trickle down that way. So it wouldn't directly affect our Great Lakes level. But, rest assured that we'll see our impacts, in the Great Lakes region. And obviously for us preserving, our most precious natural resource, the world's largest, freshwater system, in the world, to be pretty much paramount in what is going to be a changing climate. Obviously the algae is going to be a big thing, making sure that we keep our lake healthy, and we don't want it filled up with algae and it removing all the oxygen from the water and killing out, the fisheries and the fish and the wildlife and all that stuff. So, we definitely need to take care of it.
Yep.
Yeah, I do see a question in the comments here. Bev chimed in and said that she's noticed big changes in her garden the last couple of years. You know, certain plants, I've noticed it as well. You know, they could be very susceptible to longer duration events. So longer heat waves with drier weather. They may not be as drought resistant as they've been in the past. When we plant those crops and those plants with, you know, the length of the growing season, I did a garden in the backyard this year. I'm kidding you. I was still pulling tomatoes off my tomato plants, I think into the first week of November. It was incredible. I've never pulled tomatoes off, you know, that late into the season before. So it was truly incredible.
I swear that the sparrows that are above my carport have at least 3 broods in the summertime. I don't know. It just seems like there's babies up there all the time. And I wonder, you know, if that's changing their patterns too.
It very well could be migratory, birds and animals that are very, used to traditional migratory patterns. You know, they don't go by the calendar. They go by the feel, they go by how things feel. And, no doubt changing climate would make that feel different.
Uh-huh.
Friends, it is the top of the hour, so I'll pass this to David, subject.
Thank you, Chris.
You're
Thank
welcome.
you. You were fabulous.
Thank you.
Oh, well,
Yes,
thank
I
you.
enjoyed every minute.
Well, I'm very glad. And I look forward to seeing you all dark and early tomorrow morning.
Yeah,
Don't get too disappointed.
Set your alarm. 4:30 a.m. comes pretty quick.
They'll be thinking about you.
Actually,
they're
actually dreaming about you. I'll be dreaming.
I don't blame you. I would be doing the same thing, but duty calls.
Someday.
Yes. Thank you very much. It was very informative.
Absolutely.
Yes,
If you guys
thank you.
have any questions, feel free to reach out to me. You can email me at any time. I have my email address up there. So if you have any questions, I'd be happy to answer those into the future.
I'd like to point out also that in our March 16th, our lecture is going to feature Dr. Arthur Dahl, going to be presenting on the 17 United Nations Sustainable Goals, being a blueprint to achieve a better and more sustainable future for us all. He's going to be addressing us from Geneva, Switzerland.
Mm-hmm.
Oh, wow.
Great.
Yeah.
Wonderful.
And our February
Our backyard to
solar energy.
And